welcome back, and I hope you all had a good weekend. Do you ever already watched my video? So I'm going to ask a few questions, and that's going to help us to connect with what we are doing now versus what we did last week, right? Okay. So do you remember what we did last week? If you know,
Two
uh,
proportions.
proportions, yes, yes. So how many? I mean, what is so different about the proportions we were doing last week versus what we did, say, a few weeks ago?
The amount of populations.
The number of populations is no longer two, is no longer one, is two, right? It has to be exactly two. And we have talked about this last time, and I'm going to do my screen sharing. And okay, so I'm going to go back to what we did last week, and hopefully you remember this formula. So this is what we did last week. We were using this table to analyze multiple population proportion cases. And for that, what we did last week has the number of a population has to be two, exactly two. Okay, so what we are doing today, today is going to be different because we're going to consider when the number of populations is more than two. It has to be three and above, right? It has to be at least three, right? Okay. Okay, great. And so do you remember what is it called? What is this kind of test being called for what we are doing today? Do you remember what is it being called?
Hypothesis test?
Yes, hypothesis test. You are right, that's hypothesis test. But what I meant is it a z-test or is it t-test or things like that?
Z, right?
It's a z-test, right? Okay. So what we did in module 5 is the z-test. And you guys told me it should be called z-test, right? Z-test, okay. So I'm gonna write it down here. Okay. And in this week, we are dealing with multiple population proportions, and the number of populations is going to be at least three, right? I'm going to write it down here. The number of population has to be at least three. Okay, what kind of test is this called? Is it called a z-test anymore? Is it still z-test?
Chi-squared distribution.
Okay, okay. This is called a chi-square. So it's called chi-square test. So this is different from what we did z-test or t-test because chi-square test is based on chi-square distribution, whereas a t-test is based on t-distribution and a z-test is based on standard normal distribution, right? So this is the third test, the third distribution we're going to learn for this class as well. Okay, chi-square test. I'm going to quickly go over when you can use this chi-square test. I'm going to introduce the two scenarios you can use it. And as you can see in the handouts I'm sharing with you guys. So there are two types of problem we're going to talk about here. So the first type of questions you're going to see is when you try to compare more than two populations. So that's exactly what I'm saying, at least three, right? So this is the first type of a test. And for this type of test, some other textbook is going to call it goodness of fit test. Goodness of fit. And so this is the first scenario we are going to use chi-square test. The second scenario, you guys probably remember, what is the second scenario you can use chi-square test? You probably remember this. You emailed me the other day. What is the kind of test called?
Is it the test of independence?
Test of independence, yes. So there are two different scenarios you can use chi-square test. Okay, I'm going to go over each one of them, quickly, and then we're going to work on one problem with me together, and you guys are going to break out into groups and you're going to work on the second one, right? Okay, so let's quickly go over how we can solve this kind of problem. So whenever we're dealing with chi-square test, from this week onwards, you guys are going to learn drawing tables. Very, very important. You're going to learn drawing tables. Okay, so whenever you do the calculations by hand, you have to draw tables. If you're doing it using Excel stat, you don't have to do that. I'm going to show you how this can be done, but it's important that you know how this can be carried out. So you have to draw tables. And I was really kind, so I set up the tables for you guys. You just have to fill in the blanks. But when you work on the assignments, you probably have to draw your own tables, right? Okay, so let's take a look. I'm going to focus on the first scenario. We're going to use chi-square test, and that's going to be compare at least the three population proportions. Okay, because it's population proportions, so that means we are dealing with categorical data. So we can classify data into different groups. Okay, so let's take a look. So regardless of chi-square test or Z or T test, we are doing a hypothesis test. So hypothesis test, we have to make sure we are going to write it down the null and also the alternative. The null and alternative are very important. So for the first type of questions, for the null, okay, for this type of question, it's typically set up this way. So it's going to be P1 equal to some proportion, P2 equals to P3 and P4, and so on and so forth. Depends on the number of populations you have. Okay, I'm going to write it down here. So K represents the number of a population. I'm going to remind you again, K has to be at least 3, right? Okay. So for example, the example we did in class in my video this week is I was using the die rolling example. And so there are 6 populations, depends on which side of the die the die lands to. So they're going to be P1, P2, and P4, all the way to P6, right? Okay, because we're going to consider it's a fair die, that's going to be 1/6, 1/6. You probably remember it. Okay, so that's going to be the null. The null says we think the hypothetical or maybe the hypothetical theoretical population proportion of P1, P2 is all going to follow this 1/6 probability. Okay, this is our null hypothesis. Okay, so you probably remember the null hypothesis, right? Okay, so this is going to be going to be our null hypothesis. Okay, the alternative is going to be the PIs are not equal to the pre-specified probabilities. For this particular example, that's going to be 1/6. So they are not equal to 1/6. If you watch the video, you probably remember. So do I have to have P1 not equal to 1/6, P2? All of them cannot be 1/6 for the alternative hypothesis? Do all of them are different from are all of them different from 1/6?
Just one of them has to be.
Just need one of them to be different from 6, right? You don't need all of them to be different from 6, just one of them, Okay, so it's very, very important. I'm gonna write down here, just one of them. Okay, so after you write out a non-alternative, the next goal is to find out a test statistic. In order to find a test statistic, what we need to do is we are gonna set up this table. And the cell here, the very last cell pointed here, that's going to give us the test statistic. As you can see, this is the test statistic. So it is set up the test statistic, right? Okay, so there's going to be one column that's going to be the observed frequency. I want to stress here. Okay, so this is the frequency. This is not a probability. I've seen students putting down I have seen students putting down, say, 1/10 or maybe some frequency, say 2/10, things like that. This is not right because this is a frequency, right? Frequency means, so if it's a frequency, that means this is other counts. This is the counts. And the second column refers to expected frequency. I'm going to use F with a subscript E to represent it. So this one represents how many counts out of your sample you should expect to see them fall into the first group. And how many of the counts, how many of them of the sample you should think is going to fall into the second group and so on and so forth. So again, this part is going to be the counts as well. Okay, and then you learn in the video, you probably have to find a difference between those two, right? You're going to find a difference between those two, and it's going to be FO minus FE. But you probably know if you just use a subtraction, some of the difference is going to be positive, some of the difference is going to be negative. You don't want to sum them up all over because this is going to cause some kind of a cancellation. Instead, you want to square this term. So this is very important. You want to square it. And then you also want to divide it by FE, right? Okay, so what you're going to do is you're going to sum up all of them. You're going to sum up all of the entries. You're going to calculate each one, and you're going to find the sum, and the sum is going to go into this cell. I also written down the formula here. If you think this is too difficult, all you need to do is set up this table and find the sum. And this is going to give us the test statistic. Okay, because it's a chi-square distribution, we have to look up the degrees of freedom. This time the degrees of freedom is k minus 1. What is a k here? What is a k? The number of populations, right? Depends on the number of groups you have, right? If you have a die, that's going to be 6. So 6 minus 1, that's going to be 5 degrees of freedom. And then you look up the chi-square table to find a p-value and critical value. I'm going to show you how this can be done using our example, right? Okay, and so this is the first set of example, the first set of scenario. You can use the chi-square test, also known as a goodness of fit test. Okay, the second case scenario Cannon told us is test of independence. The test of independence, what we want to achieve here is, say we have 2 different kinds of classifications. The classifications means you have this data, you have a sample, you want to classify them according to different criteria. The first type of classification, for example, if we were using this module's example, that's going to be the color preference. We can classify the subjects, those people, according to their nationality. So that's going to be the first classification. That's going to be their nationalities here, American, Canadian, Mexican. A second type of classification, again, you can classify the subjects, those people you collected for your survey. You can classify according to which color they prefer. So that's going to be color preference. They could prefer A, B, C, D. So there are 4 groups here. This is the second type of classification, right? So I'm going to write it down here. So if we classify them according to nationalities, there are 3 of those. If you classify them according to their color preference, we have 4 of those. But this is not the only 2 classifications you can have for your data. For example, if you're curious to know whether there's any relationship between gender versus their color preference, so you would use gender instead of nationality in this case, right? Maybe you think there's any preference according to the state they reside in right now. So you probably want to use which state they live right now. Or maybe there are some other things, maybe education level, or number of children they have, or the size of their family, right? There are different ways to classify them. So it really depends on what you're interested in. So this is a very important technique we're going to do, test of independence, especially for marketing purpose. For example, if you want to develop a new product, how do you know people like it, right? You want to set up this kind of a survey to see whether there's any relationship between which product they prefer versus their demographic information, right? Okay. So we're going to set up the null and alternative just like what we did before. I want to emphasize here, the null and alternative is different from the previous one, even though we are using chi-square test in both scenarios. The null here, the first one is 2 classifications are independent. So you do want to specify 2 classifications. You want to specifically tell me what the 2 classifications are. You don't want to just tell me vaguely 2 classification. You want to tell me, for example, you want to change it to nationality and color preference. So you want to be as specific as possible, right? Because once you become more specific, it's going to become more meaningful for the study you're trying to work on. So nationality and the color preference. Sorry about the handwriting here. Nationality and the color preference are independent. Independent means there's no relationship. Whether people like color, the flavor A or B or C, it doesn't depend on which country they came from. And the alternative is going to be they are not independent. They are not independent. Okay, so you want to be specific as well. You want to say nationality and the color preference are not independent. What I meant here means they are dependent. There is some kind of a relationship. Maybe American only prefers B and Mexican only prefers D, right? There may be some kind of relationship. But this test will not be able to tell us what kind of relationship that is. It's only going to tell us there is or there isn't a relationship. Okay, if you want to be specific to figure out whether American like A or B, you cannot use this test to see. You can only tell us generally whether there is any relationship or not. So whether there is a relationship or there isn't a relationship, right? Okay, some other thing I want to stress here is whenever you carry out a test of independence, okay, so the null is always independent. Okay, it's always independent. Alternative is always there, dependent is always true. You know, I know a lot of people, a lot of students before the midterm, you probably are looking for research question. Over here, you do want to remember the now is always there's a independent and an alternative is always dependent. I'm going to tell you a trick to remember this. This is going to be very helpful. Okay, I'm gonna write it out here. Okay, so for the null hypothesis is always no relationship. Okay, for the alternative, there is always gonna be there is a relationship, right? No relationship and there is a relationship. And we can use this rule of thumb, not only for this week, but for other later weeks as well. I'm gonna give you more examples. So typically when you try to find a null, is there's no relationship. Okay, no relationship means the two classifications are independent. Okay, if we are trying to say there's a relationship, that means they are probably dependent, right? Dependent, right? Okay, you can use this to go back to our die example here as well. Okay, so for example, the null means there's no relationship. No relationship means this die is fair. We don't see any special pattern for surface for side 1 versus side 2 or side 3. They are all the same. No any kind of a relationship we can observe. For alternative means they are not equal to the fair die, not equal to the 1/6 probability. That means this die is probably not fair. There's some kind of relationship going on. There's some kind of pattern of behavior going on. The die looks, it's probably not fair. So this is how you know whether there's a null or alternative, how to write out a null or alternative. So this is the second rule I taught you in this class. The first rule about finding the null and alternative is to go after the research question. But after the midterm, all the tests we learn, you can use this. There's no relationship versus there is a relationship to help you to figure out a null and alternative. Right? Okay. So what we try to do here is, again, we try to we try to figure out what a test statistic, right? What is the test statistic? Okay, this test statistic can be solved by setting up this table, Okay, so you have to set up this table, and this table is going to help us to figure out the FO and also FE. Because once you have FO and FE, you can calculate FO minus FE, square it, and over FE. And because this is going to be helpful for us to figure out the test statistic. As you can see here, the test statistic is the sum of all the 12 cells. So you have to do that for each one of them. So that means you have to do this one, do it for this one, for 12 of those, for each one of them. And then you're going to sum up 12 ratios. You're going to sum up 12 ratios, right? Okay, so typically I want to stress here, FO, which represents observed observation, observed frequency. This is typically given in the question because they are the same as the information you collected from the sample. The FE part, the expected frequency, expected counts, this part can be a little bit tricky. You do one additional step to find it. But there's an easy formula for you to remember. So expected frequency is nothing but the row total multiplied by column total over grand total. I'm going to give you a demonstration, which I've already done that. For example, okay, I'm going to focus on this one, this particular cell. Okay, so this is the cell I'm looking at here. I want to figure out what is the FO. So the FO is probably easy because it's typically given to you in the question. So this part is easy. And once you figure that one out, you want to figure out the FE. FE, I'm going to use the formula which is given here, which is the row total multiplied by column total over grand total. So let's see how we can calculate the FE. Or maybe someone is going to help me. How to calculate the FE then? Who wants to give it a try? It's going to be row total, column total, divided by grand total. So what is the row total? Where is the row total? Where is the row total? Yes?
On the right side of the Canadian thing. Yeah.
Right here, right? Okay, so this is the FE. You want to find the row total right here. You have to figure out this cell. And then the column total is just, you go straight. This is the column total. And the grand total is nothing but the total sum of the entire table, right? That's right here. So you're going to use this one. sorry, this one, multiplied by this one, divided by grand total, right? And so you're gonna do the same thing for each one of them. And then you're gonna figure out the ratio. Okay, I know it sounds a little bit tedious, but if you can use Excel to do it, and in our final exam, I will not ask you guys to do a very complicated calculation. So because it's very time consuming and I don't think there's much point of testing you guys on that. So you just, read the question very carefully because the question will tell you which expected frequency to calculate. You probably don't have to do the same thing for every one of the cells here. Read the question carefully, right? Okay, I think it's the same for the quiz this week as well. Okay, so once you figure out each one of them, the ratio here, you're gonna sum them up. You can see sum up. And then that's gonna give you the test statistic. And then you're gonna find the corresponding degrees of freedom. Then you're gonna look up the chi-square table to find it.